Hey Internet. Well, tonight we're going to do something a little bit different. We're going to look at the Keyestudio 4-wheel drive Bluetooth compatible robot car V2 kit for Arduino. That's the box there, and this is the fully assembled unit. We'll do just a quick kind of walk around here. Up on the front we have an ultrasonic sensor. This is an 8x16 LED display. On board is an infrared receiver. It also has an LED over here and 4 motors that drive 4 wheels. So it's got no steering except basically for a differential drive. I think that's most of the features. There's actually a line following sensor on the bottom, which I haven't really played with. Is not really a need for what we're doing in this one now. Oh look, we have Maisie. She actually might come in handy for our demonstration today, so that's actually pretty nice. Hi Maisie! Well, what I was going to demonstrate here was a couple of the really early designs on this. Now, the Arduino kit, as it stands, comes with an infrared remote control that lets you control the robot with the programming that it comes with, either using the infrared or you can use the Bluetooth app, and it lets you basically steer the unit around or drive it around, and forward, back, left, and right. It does line following. Some of the programs incorporate like line following or distance tracking, where you can, as you put your hand in front of it, or a cat, as in this case we're going to be demonstrating, it'll kind of know where the thing is and go closer, farther away from it. But those are all fairly basic, following a single path program. And my intent here was to start programming some general behaviors using the Arduino function called prototypes. The Arduino itself doesn't have the ability to do multi-threading or multitasking, but we can use tricks to accomplish a simulated multitasking, more like time slicing. A lot of it is controlled by the programmer, so you have to be pretty careful how you're using these Protothreads. But hopefully we'll be able to demonstrate a couple of the really early designs on this one. So set our box back up, as it is part of the demonstration. So the early design here was basically just a method of using the servo and the ultrasonic distance sensor on the front to measure the distance of an object in its sweepable viewing area, and then turn the sensor back to whatever the closest object is. Now with Maisie here, don't know exactly what we're going to expect, so we'll go ahead and power it on. So what it's doing is doing a scan from one side to the other, and then turning the servo, turning the ultrasonic sensor to look at whatever object is closest, and then it displays a little sine wave on the front to demonstrate that it's got there. We will try again here, just to program or to demonstrate that it's not just turning to the right. Yeah, so it went all the way to the right and left and scanned, and then just kind of hopped over to the right a bit. We'll try in the middle. So this is the the first experiment that I did with the range sensor and the servo and the display on the front. This is all running on basically just a single thread. It doesn't display the display until it's finished, and the servo doesn't know where to turn until it's finished its task. So this is all running a single thread, kind of just testing the servo performance and the ultrasonic range sensor. I'm going to go ahead and swap out the program to the current version using Protothreads. Alright, we're back over here, and we've installed the cat chasing robot software. This is an early version that doesn't even have its wheels active yet. That's because robots never have their legs active yet. You look at Frankenstein, look at Data, look at Project Quester. They all started off on a table before they stood up and started causing havoc. So we haven't activated the wheels yet, but we do have 6 threads that run. We have a thread that operates the ultrasonic sensor, one that runs the display, one that runs the heartbeat, one that listens on the infrared pickup, one that turns the servo, but it's not active, and then we have its first behavior, which is just ping. We'll be writing behaviors that will basically be monitoring the other threads of its essentially an autonomic nervous system, listening on the ultrasonic, listening on its various sensors that we're going to install on the front. We'll have some touch sensors there as well, and reacting on those based on what it's able to detect. So let's go ahead and power it on. As it powers on, it goes into a sleep mode, and I've tried to emulate like a traditional 90s style screensaver, so it's in like a sleep mode. While it's operating, the other threads are active. The ultrasonic sensor is outputting the range out to the serial port, and the other threads are active as well, including the servo. But unfortunately, the servo class clashed with the LED, so we'll have to rewrite the servo class or rewrite our own servo routine to start turning the servo. We have the sleep mode active now. We'll use the remote here. This is the remote that came with it. Pretty standard. I'll take it out of sleep mode, put it into ping mode. Now as it goes into ping mode, the alert did go off because it saw me immediately, but then now that it knows where I am, it's not going to trigger it again unless I move. I just shifted slightly, and it did detect movement. It doesn't take much for it to see, and it is able to see quite clearly distance. But of course, it doesn't have stereo, so it doesn't know if I'm moving left or right. And that's going to be the first thing we write in the servo, is trying to help it understand which direction it needs to turn in order to find the closest object. As we saw with the first demonstration and the servo turning to the closest object, what it did is create an array of ranges and then turn the servo back to the value in the array of ranges that had the lowest number. We'll use a similar method for this method here, but we'll try and make it a little more graceful. So it'll keep more of like of an active status of all the ranges at various servo points, and then react accordingly. Well, that's the cat chasing robot so far. We have 6 threads running using the Protothread class. Arduinos don't know how to do multi-threading, but we can trick it using Protothreads. Maybe the next video update we'll have the servo operational, so it's able to turn towards whatever object that's closest and try to track movement that way. We're still a little ways away before activating the wheels, but that'll be coming too. Thanks for watching. Let's put it back to sleep. It looks tired.